Welcome to this Excel tutorial. In this video, we'll dive deep into some of the most important logical functions Excel has to offer. Whether you're looking to streamline your data analysis with the if and ifs functions, combine multiple conditions with and or, reverse logic with not, or master advanced techniques like nested if, SUMIF, and COUNTIF, we've got you covered. By the end of this tutorial, you'll have the skills to tackle complex data scenarios with ease. Let's get started and elevate your Excel game to the next level. The if function is one of the most widely used functions in Excel, enabling you to make logical comparisons between a value and your expected outcome. At its most basic level, an if statement will produce two possible results. One if the comparison is true, and another if the comparison is false. The basic syntax for the if function in Excel starts with an equal sign, like all other functions in Excel, followed by if, and then a left parenthesis. Inside the parentheses, the if function takes three arguments. First is the logical test, which is the condition you want to evaluate. Examples include checking if D4 is greater than E4, or if D4 is less than E4, depending on the specific condition you want to test. The next two arguments are the value if true and the value if false, which are the values or expressions returned if the logical test evaluates to true or false, respectively. They specify what should happen or be displayed based on whether the condition testing are met or not. Having said that, let's practice some examples to make it easier to understand. Here we have a table containing 5 account managers, their sales figures, and their target sales. We will use the if function to determine which account managers met their targets and which ones missed their targets. To do this in cell F4, we will start by typing an equal sign, followed by if, and then the left parenthesis. Next, we will type the logical test, which will be D4 greater than E4. To determine who met the sales target and who did not, we will use met target for the second argument, which specifies what the formula should return if the condition is true. In Excel formulas, text must be enclosed in quotation marks, so we will enclose met target in quotes. For the third argument, we will use missed target, which indicates what the formula should return if the condition is false. After entering this, we close the formula with a right parenthesis and press enter. We will then use the fill handle to copy this formula to the other cells. With this, the if statement evaluated the condition we provided and returned values based on whether the condition was met or not. Let's practice with the if function one more time. This time, we will use it to determine how much of the sales target was missed. To do this, in cell G4, we will type an equal sign, followed by if, and then a left parenthesis. Next, we type the logical test, which will be D4 less than E4. To determine how much of the sales target was missed for the second argument, which specifies what the formula should return if the condition is true, we will type E4 minus D4, which will return how much was missed if the condition is met. This will calculate the amount missed if the condition is met. For the third argument, we will type 0, which specifies what the formula should return if the condition is false. After that, we will close the formula with a right parenthesis and press enter. Just as we did previously, we will then use the fill handle to copy this formula to the other cells. With this, the if statement once again evaluated the condition we provided and returned values based on whether the condition was met or not. We will move on to the next function in this tutorial, the ifs function. The ifs function checks whether one or more conditions are met and returns a value corresponding to the first true condition. The ifs function is an alternative to using multiple nested if statements, which will be covered later in this tutorial. The syntax for the ifs function in Excel begins with an equal sign, followed by ifs, and then a left parenthesis. Inside the parentheses, the ifs function can take multiple pairs of logical tests and corresponding value if true conditions. You can add as many logical test and value if true pairs as needed. The function checks each condition in the order they are listed and returns the value for the first true condition it encounters. It is worth noting that the ifs function allows you to test up to 127 different conditions. However, it is not recommended to nest too many conditions with ifs statements because multiple conditions need to be entered in the correct order, which can be very difficult to build, test, and update. Having said that, let's go ahead and practice using the ifs function. Here we have a table containing various expenses and their corresponding amounts. We want to categorize these expenses into low, medium, high, and very high using the ifs function. To do this, we will type an equal sign in cell D4, followed by ifs, and then the left parenthesis. Next, we will type the first logical test, which will be C4 greater than 1,000. So we want to categorize expenses greater than 1,000 as very high, so we will put very high for the value if true. For the second logical test, we will put C4 greater than 500. We want to categorize expenses greater than 500 as high, so we will type high as the value if true for this logical test. Next, we want to categorize expenses that are greater than 100 as medium, so we will put C4 greater than 100 as the logical test, and put medium as the corresponding value if true. Lastly, we will categorize all expenses less than 100 as low. With that done, we'll add the right parenthesis and press enter. Next, we'll use the fill handle to drag the formula down to the other cells. So by using the ifs function, we've been able to test multiple conditions within a single formula, which is the primary advantage it has over the traditional if function. We will move on to the next logical function, the AND function. The AND logical function in Excel is used to test one or more conditions simultaneously. It returns true if all the specified conditions are true, and false if any of the conditions are false. The basic syntax for the AND function begins with an equal sign, followed by and a left parenthesis. Inside the parenthesis, you can include multiple logical conditions. Unlike the if function, the AND function does not require arguments for what to return if the condition is true or false. By default, the AND function returns true if all conditions are met and false if any condition is not met. With that in mind, let's practice using the AND function. Here we have a data set of 5 salespeople with columns showing their sales for the first and second quarters, as well as their sales targets for each quarter. We'll use the AND function to determine which salespeople met both their first and second quarter targets. To do this, we will type an equal sign in cell G3, followed by and then the left parenthesis. Inside the parentheses, we will type 2 conditions. The first condition will be C3 greater than or equal to E3, and second will be D3 is greater than or equal to F3. We will close this with the right parenthesis and hit enter. So as we can see, the AND function returns false, because the first quarter sales of $12,000 fell short of the $13,000 target for John. This is why the AND function evaluated the conditions and returned false. It's important to note that the AND function will still return false if even one of the conditions is not met, regardless of whether the others are true. With that said, let's proceed to use the fill handle to copy the formula to the other cells. So in summary, the AND function is valuable when you need to test multiple conditions simultaneously and require a result only if all conditions are met. As we did with this data set, it helped to evaluate whether or not each salesperson met both quarter 1 and quarter 2 sales targets. Let's move on to the next function, the OR function. While it's somewhat similar to the AND function, the key difference is that the OR function returns true if any of the specified conditions are met, and false only if all of the conditions are false. The basic syntax for the OR function starts with an equal sign, followed by OR and a left parenthesis. Inside the parentheses, you can list up to 255 logical conditions. The function returns true if any of the conditions are met, and false only if none of the conditions are satisfied. Let's go ahead and practice using this data set. So this table has 5 salespeople with their sales figures for both quarter 1 and quarter 2, as well as their sales targets for each quarter. We'll use the OR function to determine which salespeople met either their quarter 1 or quarter 2 sales targets, and which ones did not meet either target. To do this, we will type an equal sign in cell G4, followed by OR, and then the left parenthesis. Inside the parenthesis, we will type 2 conditions. First will be C4 greater than or equal to E4, and second will be D4 greater than or equal to F4. We will close this with the right parenthesis and hit enter. The function returns true because while John was not able to meet quarter sales target of $13,000, John's quarter 2 sales of $15,000 exceeds the quarter 2 target of $14,000 and hence the function returns true because the OR function evaluates and returns true if any condition is met. With that said, we will use the fill handle to copy the formula to the other cells. In summary, the OR function is most beneficial when you need to evaluate several conditions and take action if at least one of those conditions is true. Let's move on to the next function, the NOT function. The NOT function in Excel can initially seem counterintuitive because it reverses the logical outcome of a condition. If you're not used to thinking in terms of negation, it might be challenging to grasp at first. However, once you understand its purpose, the NOT function becomes quite straightforward and powerful in specific scenarios. Essentially, the NOT function returns the opposite of what a condition would typically return. If a condition is true, NOT makes it false, and if it's false, NOT makes it true. The basic syntax for the NOT function starts with an equal sign, followed by NOT, and then a left parenthesis. Inside the parentheses, we will place the logical condition we want to evaluate. If the logical value is true, the function will return false, and if the logical value is false, the function will return true. Let's go ahead and use this data set to practice. We have a table with a column for 5 clients, a column for payment received, and another column for payment not received. We'll use the NOT function to determine clients whose payments have not been received. To do this, we will type an equal sign in cell D3, followed by NOT, and then the left parenthesis. Inside the parentheses, we'll type the condition, which will be C3 equal to Y. We will close this with the right parenthesis and hit enter. As we can see, when the condition is met, meaning C3 is equal to Y, the function returns false. If we drag this formula down to the next cell, the function will correctly return true when the condition is not met. As we have demonstrated, by inverting conditions, the NOT function helps you highlight exceptions, errors, or situations where a condition is not met. Let's move on to the next function, the nested if function. The nested if function in Excel allows you to test multiple conditions in a sequence, providing different outcomes based on the results of these conditions. It involves placing multiple if functions inside each other to evaluate complex criteria, and this is especially useful when you need to determine values based on more than 2 possible outcomes. The syntax starts with an equal sign followed by the if function and then a left parenthesis. Inside the parenthesis, there is the first condition to evaluate and a value of true if the first condition is met. Next, there's another if function with a second condition and its corresponding value of true. You can continue nesting if functions to handle additional conditions, up to 64 different if functions. However, using too many nested layers can make the formula complex and difficult to manage. The nested if statement will include a value to be returned if none of the previous conditions are met, along with the appropriate number of closing parentheses to match the number of nested if statements. Let's go ahead and practice so it's easier to understand. Here's a list of 5 employees, along with their performance scores, sales targets, and actual sales. We want to determine their bonus eligibility based on the following criteria: a high bonus if the performance score is 90 or above, and actual sales are at least 110% of the sales target. A standard bonus if the performance score is 80 or above, and actual sales meet or exceed 100% of the sales target. And no bonus if the performance score is below 80 and actual sales fall short of 100% of the sales target. To do this, we will type an equal sign in cell E4, followed by if, and then the left parenthesis. Inside the parentheses, we will type the first condition. In this case, we'll use the AND function to check if the performance score is 90 or above, and if actual sales are at least 110% of the sales target. So we will put AND open parenthesis, B4 greater or equal to 90, D4 greater or equal to 1.1 multiplied by C4. We will put high bonus as the corresponding value of true. Next, we will include another if function. This time, we'll use the OR function to check if the performance score is 80 or above, or if the actual sales meet or exceed the sales target. We will put standard bonus as the corresponding value of true. Lastly, we'll set no bonus as the value to be returned if neither of the conditions are met, and close the formula with 2 parentheses to match the 2 nested if statements. And hit enter. As shown, the nested if formula correctly assigns a standard bonus to Alice, as her performance score of 85 and actual sales of 120,000 meet the conditions required for a standard bonus. With that said, let's use the fill handle to copy the formula to the other cells. To summarize, the nested if function allowed us to assess multiple conditions within a single formula, providing a way to manage complex decision-making scenarios such as assigning performance ratings or bonuses based on performance metrics in this case. Let's move on to the next function, the SUMIF function. While adding numbers together using the sum function in Microsoft Excel is a basic task, there are times when you might want to add values only if they meet certain criteria. This is where the SUMIF function becomes useful. The SUMIF function in Excel allows you to sum values within a range that meet a specific condition or criterion. It's especially handy when you need to total only particular data within a larger data set. The basic syntax for the SUMIF function starts with an equal sign, followed by SUMIF, and then a left parenthesis. Inside the parentheses, the SUMIF function typically takes three arguments. The first is the range of cells to evaluate. The second is the criteria or condition that determines which cells to sum, and the third is the sum range, or the range of cells to sum if the criteria are met. Let's use this data set to practice the SUMIF function. It contains information about various products sold in different regions, with each row listing the product name, the region of sale, and the corresponding sales amount in dollars. We'll apply the SUMIF function to calculate the total sales for apples across all regions. To do this, we will type an equal sign in cell E3, followed by SUMIF, and then the left parenthesis. Inside the parentheses, we will type the first argument, which is the range of cells to evaluate based on the criteria. For this example, it will be A3 to A12, as this range contains the criteria we want to assess. Next, we will set the criteria as apples, because we want to sum the sales specifically for apples. Finally, we will set the sum range as C3 to C12, which contains the sales amounts we want to total if the criteria are met. We will close with the right parenthesis and hit Enter. As demonstrated, instead of manually summing specific rows containing sales for apples, the SUMIF function enabled us to perform the operation in one step, saving time and effort. We will now move on to the final function in this tutorial, the COUNTIF function. Similar to the SUMIF function, COUNTIF also aggregates data based on a specified condition or criteria. However, instead of summing values, COUNTIF returns the count of cells that meet the given condition. The basic syntax for the COUNTIF function begins with an equal sign, followed by COUNTIF and a left parenthesis. Inside the parentheses, there is two arguments typically. First, the range of cells to evaluate, and second, the criteria or condition to determine which cells should be counted. We will go ahead and use this dataset to practice the COUNTIF function. Here's a dataset tracking financial transactions over a period of 10 days in August 2024. It includes 4 columns: date, transaction type, amount, and category. We will use the COUNTIF function to determine the number of income transaction in this period. To do this, we will type an equal sign in cell F3, followed by COUNTIF, and then the left parenthesis. Inside the parentheses, we'll type the first argument, which is the range of cells to count according to the criteria. The second argument will be the criteria, which in this case will be income. We will close with the right parenthesis and hit Enter. The formula then returns the count of income transactions. As shown, the COUNTIF function is simple and easy to use, enabling you to quickly count cells based on a single criterion without the need for complex formulas. With that said, that wraps up our tutorial on logical functions in Excel. I hope you now have a clear understanding of how to use functions like if, and, or, and not to create more powerful and dynamic spreadsheets. Mastering these functions can significantly boost your data analysis skills and save you time. If you found this video useful, please give it a thumbs up and consider subscribing to our channel for more Excel tips and tutorials. If you have any questions or need further clarification, don't hesitate to leave a comment below. We're always here to assist.